hi everyone. We have Deніел Wайтson here, and he's a particle physicist, professor of physics and astronomy, and popular science writer who wrote, well, actually we have this one translated into Ukrainian. This is your book, We Have No Idea, that you've done together with Jorge Chem. And we'll sometimes I'll refer to this book. And actually, I have a couple of questions.
Well, thank you very much for having me here. Happy to answer any questions. There are no dumb questions or weird questions. They're all just, we're humans being curious and trying to understand the universe. So every question is welcome.
Thank you very much. The first thing I wanted to start here today is to talk about really weird things, and to ask you what is the most, what is the weirdest, the most mind-blowing, the most bizarre thing in the universe, or a concept or theory or, paradox for you, the one that drives you the most, like more than any other one, if there is such one.
Yeah, wow. What an amazing question. To me, one of the deepest questions that keeps me up at night is wondering whether the universe can be understood. The whole process of physics is let's try to explain everything we see. And we sort of assume there that it's possible. And so far, it's worked really, really well. But we don't know why. Why is it possible to explain the universe, to write little mathematical stories that work, that can predict how a ball flies through the air or how fluid flows down the hill? We don't know why that's possible, sort of in many ways. And we just can keep trying to figure out the universe and keep hoping that it will continue to be possible. But it could be that we reach some point where there is just no explanation that we can find, or the universe is not operating based on some fundamental law. It seems maybe a little philosophical, but to me, it's incredible that it ever works. If you think about the universe as just a bunch of particles and they're bouncing against each other and interacting, we'd like to believe that somehow the way those particles weave together and do their thing, that makes the universe that we live in. Oranges and apples and blueberries and all those things are just made out of particles, right? But that's not something that we really understand. Like, why is it that you can go from a universe with so much complexity and the smallest stuff, and then when you zoom out, it's actually pretty simple. Like, you don't have to understand all the particles inside a blueberry in order to roll it down a hill or to throw it through the air. So to me, it's a bit of a mystery why the universe makes any sense, why it's possible to figure it out at all. And I wonder how much we will be able to figure it out, or if we'll someday hit a blockade where science just doesn't work anymore. It's just not something that the universe guarantees for us.
Thank you very much. It's really very interesting. And also, I like how you started answering that question. You said that it's one of those questions that keeps you awake. And it makes me want to ask you the next thing. Was there something in your childhood that actually kept you awake? Some questions that you remember from your childhood, probably something that you couldn't verbalize because of some lack of the words, lack of some understanding the fundamental, concepts, but you still had those questions. And I know that you were the one who used to smash 2 rocks to get more rocks, and which is probably, the reason why you became a particle physicist. And I remember it because you said it in your TEDx. So do you remember some crazy questions from that period of time, and how you used to formulate them, how you used to think about them, the ones that kept you actually awake the whole night?
Yeah, what a wonderful question. I do remember as a kid struggling to try to understand why space has 3 dimensions. You think about, like, one dimension is a line, you can move back and forth along it. 2 dimensions is a plane. So you take your line, you add another line that's perpendicular, So now you have a plane, you can move anywhere on a surface. This is all fine in our brain. Now, third dimension is perpendicular to the plane. So now you have like a volume, like a cube or something. You can move anywhere in that space. And I remember wondering, like, where would the next one go? Like, if you need to add another line that's perpendicular to all three lines, it felt like there just wasn't room for it anymore. And to me, that means that, like, okay, the space we live in, the way our brains work is three dimensions. But what if there are four dimensions? What if there are five dimensions? What if there are 10 dimensions? And I remember as a kid just struggling to like get that into my brain, like to try to think in four dimensions and wondering, like, are there four dimensional beings out there for whom it's like totally obvious how to think in 4D? And or was it possible if I concentrated on it hard enough, or if like did mental exercises, if I could somehow get my brain to work in four dimensions? This is me at 8 years old, like trying to grow my brain into the fourth dimension or something. Never figured out how to do it. Still struggle to like mentally visualize four dimensions. For me, physics is really like a visual geometric thing. I think about shapes and patterns and how they fit together much more than I like read equations or mathematics. Some people are different, you know, some people learn best with symbols on a page. For me, everything is like geometric. And so I still struggle to think about that. And that's still a question in physics. Like, are there more dimensions in space? Are there 4, 6, 11, 26 dimensions, and we are only experiencing three of them? To me, it's so endlessly exciting, but also frustrating that there are such basic questions about the nature of the universe that we don't know the answer to. And and that in a few hundred years, if they do figure this out, people could be like, haha, remember back then when they didn't even know that we were in 4 dimensions or 20 dimensions. And the most frustrating part is that probably the answer is obvious and the clues are right in front of us. We just don't know how to put them together. You can look back into the history of science and find so many times when it took 200 years to understand something, but everything was there. All you needed was like the right person and the right brain and the right afternoon and a good cup of coffee or something to click it all together and moment of insight. But it took hundreds of years for that to happen. So I'm frustrated that could be possible right now. Like we could sit today on this call right now and put together all the information we need to understand the universe more deeply, if only we could see it. So it's anyway, I thought about that a lot as a kid, like how to make that kind of progress and if that's possible.
Have you read this novella Flatland when you were a child?
Yeah, absolutely. Hmm.
Well, we started talking about childhood. One more question, and then I'll go to something I wanted to ask you. What was written also in this book? Sorry for this little off top about myself, like a little bit of introspection. But I remember when I was a child, I wanted to have a magic wand that would, not like give me all the toys that I dreamed of, but would magically provide me with all the answers I needed. And most of those questions that I asked were really, really dumb. Like I remember I was, I could sit there and just think like how many people in the whole world are right now like picking their noses. Like for example, like how many of them doing this right now? I want to know the exact number. Or like how many people are thinking this thought of how many people are thinking this thought? Like can we be like connected right now? And I was a kid
Yeah.
and I was thinking I want to have this statistic, but I didn't. And we also didn't have even like Google or social media to even come close to this data. But let's imagine that we have this kind of wand right now, this magic wand. Maybe it's not wand, maybe it's like a powerful supercomputer, and using it, you can get an answer to anything, like basically anything, but it can only be one question. It can be about like either dark matter, other dimensions, whatever, secrets of time, multiverse, whatever, or probably even what happens with your consciousness when body dies, anything, but only one question.
Wow. Only one question. Wow, that's hard. That is hard. But what you say really resonates with me because it's so exciting to think that there is an answer to this question. Like what you said, how many people are eating an ice cream or how many people are thinking this thought? That's a number. It exists, right? It is a fact in the universe. It's just one that we don't have. And so to me, it's exciting, but also frustrating that some of the basic questions we want answers to, there are facts, like how was the universe begun? Like there's one way that it started and no other way. And that's just a fact. Um, but if I had to choose, I think I would want to know if there are intelligent scientific aliens in the universe, because that would just change what it's like to be human. If there are not any others in the universe, that means something amazing about us and our existence here. And then if there are, it means something incredible about what we could learn and how life is spread around the universe. So I would choose that because either answer is amazing, is mind-blowing, and changes the whole context of your life. And for me, physics is about understanding the universe, but it's also philosophical and emotional and personal. It's about understanding our role in the universe, how it all works, changes how it feels to be human. And I think the answer to that question would really change what it feels like to be human, regardless of whether we learn that we're alone or that we're not alone.
Yeah, both answers are really, I don't know, they are scaring actually. In this book, you mentioned how scientists first reacted to the idea of some start point to a universe as of something really dumb, because it like has always existed. It couldn't be tiny, and it's weird to think about that. And even the name Big Bang was just an irony to it at first. What do you think, if we can speculate a lot here, can what can be an irony to scientists now, but might probably work in future and become a serious theory or serious like some concept or whatever, like time traveling or intelligent people made of dark matter or something else? What do you think is now stupid, but probably it can be something?
Yes, well, you're asking a very important but maybe impossible question. We are limited in the kind of ideas we even consider about the universe because of what we think is natural. But what we think is natural, depends on culture and history and all sorts of, things that are not fundamental to the universe. And so I feel like we have like blinders on, we only consider some kinds of ideas because they make sense to us. But there are other ideas which later are shown to be correct and make perfect sense later on. And so basically what you're asking is, what are we blind to? What are we not considering because we think it might be bonkers, but it also could turn out to be reality? And if I knew the answer to that question, I would know what kind of ideas to explore and propose. And you're basically asking for a genius insight. It'd be wonderful to know the answer to that. One thing we can do, though, is to explore, right? One way to make progress in the universe is have a bunch of genius ideas and then go see if they work. The other way is to be open-minded and explore and let the universe surprise you. One example is the discovery that the universe is expanding and that that expansion is accelerating. Just like 20 years ago, we learned that yes, the universe is expanding, but something out there is pushing on them farther, harder and harder, so that space is growing between stuff faster and faster. And that was not an idea anybody took seriously, 20 years ago, but they discovered it. And when they discovered it, they were able to recognize it, like, wow, the universe is telling us that none of the ideas we had are valid and something else crazy is going on. So I think we also have to leave a lot of room for experimental discovery. And that's why I think it's important that experiments are done not just to confirm or reject theories, but to explore. The same reason why we land a rover on Mars and let it wander around, because you never know what it's going to find. We need to do experiments that are just open-minded exploration to let the universe confront us with the weird reality, the weird but wonderful and delicious reality.
Thank you very much for this answer. I also wanted to ask you something that's like slightly about dark matter, but actually not quite. Well, actually, when I read, things like dark matter, dark energy, or something which is seen and observed on the cosmic level, it kind of abstracts me from all the, stress that I might experience here, because every day some crazy things are happening around, but it's really these mind-blowing stuff. When you read about them, your brain just goes, I don't know, my brain just goes to some kind of another just dimension, I would say, metaphorically. So yeah, I was thinking when I was reading about the dark matter, on this question that I'd like to ask you: could we possibly have not come yet to another form of communicating, like with matter, as we have electromagnetism, weak force and strong force, which is why we don't know what dark matter is, but only see it interacting with the gravity. So is there any possibility of some force that's hidden?
Yeah, you're asking, is it possible that dark matter does feel some force other than gravity, a force that we also feel, but we just haven't discovered yet? And that is possible. It's possible that there's some additional force that's very, very weak. If the force was strong, if it was as strong as electromagnetism or the strong force, we probably would have seen it already, because dark matter is everywhere. And so if it interacted very strongly with our kind of matter, we would see it, even if it's not electromagnetic. And people are looking for dark matter all the time, and they haven't seen it, which means that if it's there and it does interact with us, it interacts very, 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 very weakly. But it's possible. Yeah, it's possible that there's a new dark force, and people are looking for the particles that would mediate that force. Often we describe a force in terms of particles that transmit that energy. Like electromagnetism has a photon, and when two electrons are pushing against each other, you can describe that in terms of the passing photons back and forth. So people are looking for some new dark force, which might have like a dark photon passing them back and forth. And so it might be that we discover dark matter directly by seeing it push on stuff using dark photons. People are also just looking for dark photons. Like if you could discover the dark photons themselves, that could tell you that there is another force out there in the universe. That's a new opening, a portal to the whole dark sector, and let us interact with the dark sector. But it's also possible that dark matter doesn't feel any other forces than gravity, that it's just totally neutral, and it just sits there and is massive and does nothing else. And that would be so challenging, because it would make it very, very hard to really understand what dark matter is and what it's made out of. So we hope there's another force out there, and it is still possible.
What about particles themselves? Why is it so complicated with them? Why are there so many of them? And do you think that one day we will discover like another layer of reality where we'll find out there's some even less, even like more like tiny than what we call fundamental right now?
Yeah, well, first of all, you say there's so many particles. All right, there's like 12 particles of matter. But is that really so many? I mean, think about all of the complexity of the universe, right? You have stars, and you have ice cream, and you have cats, and you have rocks, and it's a lot of different stuff that are all made out of a few basic particles. That's pretty amazing, right? It's incredible that you get this huge complexity of stuff in the universe built out of just a small building blocks. So I think that's already pretty great. But it's a great question to ask, like, could it be simpler? Is it possible? And absolutely, we do not understand why there are all the particles that we have currently. Like, why do we have these 12? And as an analogy, if you look at like the periodic table, zoom out for a minute, pretend you didn't know about the particles, look at the 100 elements of the periodic table and say like, well, why do we have so many? Why do you need so many different kind of things to make up the universe? Where do they come from? Are there smaller pieces that they're made out of? And the answer we know already is yes, absolutely. Those are all made out of a few smaller pieces. And so we take inspiration from that and say, what if the quarks and the leptons, the up quark, the down quark, the electron, all these particles are made of a few even smaller particles? Absolutely, it's possible. And it's likely that there would be a smaller number of them because as you go down, things tend to get simpler. And all of the complexity at one level, like the blueberries and ice cream, are all made out of a few basic elements. And those elements are made out of an even smaller number of particles, which are made out of even smaller number of particles. So we hope that the trend suggests that eventually we'll get down to something where it's just like one particle or two particles, and that maybe that's the fundamental layer of the universe. It could also be that there is no fundamental layer, that it just keeps getting smaller and smaller and smaller forever, like literally forever. That if you spend infinite time and infinite money and infinite energy, keep smashing particles together, you just keep finding smaller and smaller bits. We don't know. We'll just have to keep looking.
What about this? I don't know if conflict is a good word here, but let's use it. Conflict between the theory of relativity and quantum physics. How should we do what should we do with them both? Because as far as I understand, both theories cannot be correct, even though they both work. But we really have to either, I don't know, what should we do with at least one of them, or how to find something else that will finally unite them? What do you think? What's your opinion on how this conflict might be resolved?
Yeah, great question. We would love to know how to bring these two theories together. So far, both theories work, but we have no situations where we need both theories. Either you're in a situation where things are so big, so there's gravity that you can measure, but then they're too big for quantum mechanics to be relevant, which is only really relevant for small stuff. Or they're so small that you need quantum mechanics, but then gravity is irrelevant because there's almost no gravity on tiny little particles, and gravity is really weak. So what we really need is a place where both of them are important. We need the universe to tell us how this works. We spend a lot of time thinking about how to bring the two theories together, maybe this way, maybe string theory, maybe loop quantum gravity, maybe something else. Those are all fine ideas. What we need is the universe to show us what happens. In the end, physics is about describing what happens. And so we need a situation where gravity and quantum mechanics both have something to say. That's very challenging because you need a lot of mass and you need things to be small. So that means we need to either go inside a black hole because that's where things are very massive and very small, or build a huge particle collider that could create a lot of energy in a collision really, really small, where so much energy that gravity is important. That would be an enormous collider. Or people are working on ideas to do quantum gravity experiments to force the universe to reveal to us what happens without going inside a black hole or building a $10 bajillion collider. So I think that's a great way forward. People have some clever ideas for what they call tabletop quantum gravity experiments. They use some really clever ideas to force the universe to show us how this works. So far, they haven't happened yet, but there are plans to build them in the next few years. And so I really hope that that's the way forward, is clever experiments to force the universe to show us what the rules are. Then we can figure out how to describe them mathematically and what they mean about the nature of reality.
We speak a lot about things we don't know or probably don't know yet, but we know we don't know them because of many other things we already know. And our picture of the world is now much more complete than ever. Do you think can it be the reason for like some people, some scientists, or maybe humanity in general, the reason of being in more despair than people in previous eras, more like frustrating comparing to other periods when things were more mysterious and probably less difficult in the same time, like even comparing to the age of enlightenment, with its all intellectual and philosophical rush, where people who had a degree, they could probably felt like their knowledge was essential and they might have felt closer to the truth. I mean, everyone who studied hard enough, while now you can be a PhD or professor or something, but still realize that you know almost nothing comparing to other things you don't know. Which period of time do you find more inspiring for people involved in science, and why?
Wow, that's a wonderful question. Would I prefer to think I know more about the universe? Would I prefer to think I know a larger fraction of the universe, but actually know less? Or would I prefer to know more, but be aware that I know a tiny fraction? I think it's exciting to know that you don't know that much about the universe. So I definitely prefer to live now because on one hand, we understand everything a lot better than people did 500 years ago. And we know that there are things to be discovered. And I don't think that that's leads to despair. I think that's leads to excitement. That's like, wow, future discoveries are ahead of us. There are moments in the future when we will learn something about the universe that blows our little minds, that makes us realize that the universe is totally different from everything we imagined. And that's why I do science. I'm desperate for one of those moments. I want to make that discovery. I want to have that experience of transforming my understanding, of pulling the veil from my eyes and seeing reality for the way it really is and not some assumption we've laid over it. So I'm very glad to know that there are huge discoveries in our future, to know that there are things we don't understand about the universe, as long as there's still hope that we will figure them out, that we will make progress. It would be very frustrating to think that there are things we don't know and will never know and could not understand. That's why my first answer to you today was that I was terrified that there are things in the universe that might never make sense to us. Or, imagine a scenario like aliens arrive. They're very advanced. They figured out the universe. They try to explain it to us. And we basically go, huh? And it just never makes sense. And like the answer is right there. They figured it out, but their brains work in a different way and they don't use math or something or a different kind of math or some whatever. And it's totally possible. It's possible that our brains are just not equipped to understand the universe. So that to me would be more terrifying, to know the answers are there, to even have access to them and not be able to comprehend them. Oof, that gives me shivers.
Wow, thank you. Thank you very much for this answer. It's really like the first part of it is really inspiring. The second part of it is really, really interesting. And speaking about aliens and your two previous answers, do you imagine sometime, I know it's impossible to check it, but still, can we like imagine, and have you ever thought about such a scenario in which intelligent beings from even from neighborhood galaxies could actually communicate with each other without any problems long, long, long time ago, when galaxies were closer, when galaxies were young and they weren't as far from each other as they are right now. And it was like kind of an era of, probably also enlightenment, but in the scale of the entire universe. And we're just late for the party. We're the ones who appeared suddenly somewhere long, long, long after everything was already probably discovered by many, many other cultures who could talk to each other. Because now the distance is too huge, and in our future, everything will only get worse. In, I don't mean our future, but I mean the future of the universe. Our skies will be completely dark. But back then, it was maybe, you know, maybe they really knew something. What do you think? Have you ever thought about such weird and, you know, bizarre? I told you some questions will be really weird, so that's one of them.
That's not too weird for me. I love those questions. Well, you know, it's possible that alien civilizations were created or existed and flourished and figured everything out billions of years ago. Because, you know, if the universe has been around 14 billion years and galaxies are 13 or 14 billion years old, the basic ingredients for life have been around for billions and billions of years. So there's nothing preventing life from evolving and figuring out these things billions of years ago, and maybe even still being around. Imagine a alien civilization that's billions of years old. What do they know? Wow, I would love to know. Is it possible that they were in contact with each other earlier in the universe when they were closer together? Wow, what a cool question. First, I think, you know, you don't need to go that far back in the universe for aliens to be accessible because the universe clumps us all together in galaxies. And while galaxies are getting further and further apart, galaxies themselves, the stars inside galaxies are not. So we're not further away from stars than we were 10 billion years ago. You know, the Milky Way is holding us all together. And the Milky Way is huge. You know, it's hundreds of billions of stars, and it's not so big. So I think there's plenty of time for intelligent aliens to send signals back and forth or to send probes across the Milky Way. You know, the Milky Way is like 100,000 light years across and tens of billion and more than 10 billion years old. So there's plenty of time for messages to go back and forth within the Milky Way. So I don't think you even need aliens in other galaxies. There should be plenty in our galaxy to talk to. But you're also right that earlier in the universe, those galaxies were closer. And so it was more possible to communicate with other between galaxies. But even back then, the distances between galaxies were vast, like really far. Now there's millions of light years between galaxies, but you know, they never were very close. You know, the universe had already expanded a lot before galaxies collapsed into stars and formed. So I don't think they were ever close enough to be as close as stars within the galaxy. So I think that's the place we should concentrate on communicating with aliens. Um, It'd be frustrating if there were aliens, but just not in our galaxy. If there were intelligent aliens and just in only in other galaxies, that would be very, very weird. If we were alone in our galaxy, but not alone in the universe, then that would be very unlucky. That'd be like the universe conspiring against us. Um, that's a depressing thought.
Wow, thank you very much.